boys basketball potluck in the Commons, and 6 o'clock tomorrow night, girls basketball banquet in the Commons. And we need help with the freshman impact. Yes. We'll meet in the lobby tomorrow evening, March 29th at 6 o'clock in the Commons. Wanting to help with that. Another way to volunteer for the day, the officers elect as soon as possible. All freshmen will take part on April 25th. They're not eligible to help, obviously. Any volunteers, sophomore, seniors must be eligible to do so. Boys State applications, for those who received that information the past couple weeks and months, are due on the Friday of this week. Please check your email for directions. Mrs. Applin or myself in the office if you have any questions. Freshmen, those of you eligible to leave for Spartan time due to the first 3 quarters receiving all A's and B's for each reporting period, you received an email this morning along with the form that is required for you to begin that process. Please check that email and take the form home. You must have that signed by one of your parents and your Spartan time teacher before you turn it into the office. Spartan time lifter of the week this week, Bradley Grubb, Richard Nehouse. You're showing great commitment and energy in the weight room. Congratulations to Bradley and body weight power clean last week. Keep up the good work and enjoy your parking spaces for the week. Juniors and seniors, your prom out of school underclassmen forms are due in the office by April 7th. Next week by 8:30 a.m. Seniors interested in Build Dakota Scholarship, that deadline is March 31. That is this week on Thursday. If you plan on attending tech school, make sure you apply for the Build Dakota Scholarship. All, please stand for the pledge. To the flag. United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All have a great day.
If you remember our discussion from Friday, it says make 2 reasonable models and explain which is more appropriate. There is a correct answer there. I said a lot of times when we make multiple models, your answer might be a little subjective. You have to qualify it with an explanation. There is a correct answer here for a very specific reason. Now these take a little bit longer. That's why there are only 2 for your homework assignment. But we do need to get motor in here, so I'm going to give you about a minute to wrap it up. Okay. Okay. 8:31. First up, I'm going to be throwing a bunch of data in here, and I used to put a bunch of other stuff in there, so I should probably second plus 7, enter 2. Okay, get completely starting over. I'm going to put data in my table, so I'm going to stat, I'm going to stat. I'm going to stat. Come on, Frank. And we type. We say 0, 15, 30, 45, 60, 75, 90. Right there, what do I already know? I can't have log because 0 was literally one of my data points. Okay, right from the get-go. What's that, 1.5? So over here we'll go 1.5, 3.2, 4.5, 15.6, 28, 37.8, and 49. Double check your data, make sure there's no fat finger errors, and game on. If I'm going to find the most appropriate model, two things I want to do first. First, I know I'm going to do some sort of model, so I'm going to want my correlation coefficient back on. If I got to go to the catalog, that also works. Second, catalog to the D's, diagnostics on. Next up, I want a stat plot. I'm going to turn plot one on. Make sure it's a correct list. I'm going to switch this over again because none of my lines are going to be orange. I'll switch it over there. And then I zoom stat so I can determine which of my models I should even attempt. So looking at this, logarithmic is out. Linear, maybe. Okay. Got that little hump right there, so probably not quadratic, but it still fits a general curve to it, so just about everything's fair game. So I am going to go through and stat calculate, and I'm going to start dumping stuff in. I'm going to start with a line, just in case, putting in y1. Now I'm just going to write my correlation coefficients. So we've got 93.8 stat calculate, because when I trace them, I'll see the actual equations anyway. I'm going to try a quadratic, dump that into y2. Okay, now we're at 98.7% stat calculate. Okay, our other models we're not going to do log, exponential, y3. Come on, Frank. 95.9 and change, so we'll say 96. Stat calculate. Try power regression. And go y4. Error domain. Why is power not working? Okay. Power regression is when I have x to a power. And one of my x's was 0. Well, if I take 0 to a power, any power, what happens? 0 times 0 times 0 times 0 times 0 times 0 is 0. There's no way to get this data point if I use power regression, so that got thrown out. And then stat calculate, we'll see how long it takes, logistic regression. Put that in y4 instead. Thinking. Okay, so we know logistic is going to pop up without one of these correlation coefficients. Right now, which of these would you choose? I would probably choose my quadratic, because right now my quadratic is the most reasonable in terms of, it's got the best fit, the highest correlation coefficient. And then I go and get logistic. So I look at my graph. We got a line. Again, lines ain't going to fit curves very well, but sometimes they're better for extrapolating. The parabola was meh. The exponential was also meh. That logistic looks good. It just looks good. Okay. Now, it doesn't have a correlation coefficient with it, but it definitely hit the most points. So I need to extrapolate to figure out, I got a question over here that's like 125 ads and 60% people. So I at least need my words. I need my window to match what is possible data. So the lowest number of ads I can run is 0. The highest number of ads I can run, Jesus, well, you see it every November. I don't know, I'll go out to like 200 and see what happens. What's the lowest number percent of people you can have? 0 people. What's the highest percent of people you can have? 100. But if I take this up to 150, actually, let's just do 100. Okay, and then I graph. Doop. Okay, so this is really my reasonable window. Not just reasonable, but feasible. You can't have 120%. Doesn't make sense. So I get my models. Okay. Based off of what we see, what are the 2 most reasonable models to choose? Logistic for sure, and the quadratic because it had the highest correlation coefficient. Remember, we're asking interpolation, pick the one with the highest correlation coefficient. Extrapolation, pick the one that has the most reasonable data. So we're going to say our 2 models are about trace, there we go, that guy. You're going to have to help me out with the rest of the decimal train. So about 0.005x squared plus 0.119x plus, what was the last part? Or the logistic model. I'm kind of wishing I would have actually wrote it down. We'd have A 55.861. Oh no, divided by. Used to their ABC being in the wrong spot. 55.861 over 1 plus 50.24. The 0 or 8? That's 0. E to the negative what x? 0.061. Okay. So, use the data to create 2 reasonable models. Bam, bam. Which one's going to be more appropriate? Okay, now when we talk about which one is more appropriate, we really do have to take into account what this problem is about. Since my output, my Y value is percent of people, well, it doesn't make sense to keep running more and more and more and more ads. Let's say I'm at 150 ads. It doesn't make sense to use that quadratic that goes past 100%. So even though it fits pretty well inside the data, remember when we saw these things actually being drawn through there, the logistic actually fit it better, like just visually. So I should choose logistic specifically because I cannot go past 100%. Okay. And then we'll actually answer our questions here. Use your model to predict the percent of disaffected voters after 125 ads. So I will come down here or in my ask table, trace to 125 ads, and I see 54.9 and change percent. So I'll say, and very related to it, after how many ads will 60% of people just not care anymore? It never hits 60. Okay, and that's assessing whether you remember that we said that C value is the natural limit. If that C value is 55 and change, when will we ever hit 60? Never. Never C equals 55.861. That's my limit. Okay. So even with doing every single step of it, doing multiple regressions, and walking through and explaining and asking questions, that's still 10 minutes instead of 15 plus. Did you have your two models? Were they correct? Did you choose the correct model, saying something about percentages, something about you can't have infinite percentage, maybe? Okay. You have some explanation saying logistic has to be the way to go. And then your two answers for the questions below. The two models, what you chose and why, the two answers. Okay. Sometimes making that choice is difficult. So I'll tell you that on the review and all forms of the test, the one problem like this, I tell you which model to make. Okay? I'll tell you which model. So, no one asked all weekend, and there were only the two problems. It was just monkey button pushing and then answer those questions. Talk to me, Goose. Anything? I hope that by now, halfway through the semester, even if you didn't use the calculators much in Algebra 2, by now we're like, yeah, I got it. We good. Okay? With whichever kind you use. Like, Emma's got the Casio. Zoe, second hour, she's got the Casio. Like, I had a couple who have different versions of. There was someone who had, I forget what it's even called, some off-brand like Cognia or something. They know how to use it. Like, you got to know how to use the tool you're going to use. Speaking of, where's my this weekend's ACT kids? Okay, just like I do with everyone. If you need to check out a calculator, you can. Use the calculator you are familiar with. Okay, that you know the best. All right, then we review. Be happy to know. I time run this one. You're looking at least a 20% reduction in time off of the last test. This one's much faster. Which also means if we get to the buzzer and the bell rings and you still have half of the test not done, that says something. Everyone got one? Good to go? All right. Womp. Okay, no review problem on this one because we covered whopping 5 sections in 5 days. Or was it 4 sections? It was 4, but one of them was long. Start with graph a thing and tell me all the stuff about it. Can you graph it by transformations? I know you can graph this by plotting points in a table. Can you graph it by transformations? Because that's the fallback option. I want to know if you can do it for real. What is the feature we always start with a logarithm? Okay. We would start with f of x is going to be log base 3 of x. What is the defining feature of a logarithm? The first thing that you put on the graph. Okay, vertical asymptote and that point, 1, 0. Okay, so I would have had a vertical asymptote at 0 and a point at 1, 0. How will those get affected by what's right here? Will I move left or right? Up 1. Is there parentheses or is there not? Okay, if you need to put the parentheses right there to show yourself that it is only on the X, that +1 is in the K spot. So I won't move that asymptote left or right at all, but I will move this initial point up 1. Okay, and then what I'm doing is I'm kind of treating this as my crosshairs of where I'm going to start. Everything goes from that point. I'm going to use powers of 3 instead of them going up like this. My negative A value tells me I'll reflect them, so we'll actually head down. And the vertical spacing between them is half as big. So instead of going down 1 over 3, down 2 over 9, down 3 over 27, instead, it's going to be half that distance. We'll go down a half and over 3. We'll go down 2 halves, or 1, and over 9. We'll go down 3 halves and over 27, which I already don't have room for. I'll go up 1 half and over a third. Up 2 halves and over a 9th. And a 27th. And a 81st. And on and on and on. And we see that it's going to curl along that asymptote. And then take off. Now again, you can get those points by just plotting points from your table. That's okay. But you have to have points on there. You can't just wing it. Okay, when I see someone who just that and it's kind of in the right spot, nuh-uh, you ain't getting credit for that. Okay? So you graph it however you're going to graph it. I'm going to talk about the transformations because that's how I graph. That's how I like it. But you graph it however you're going to graph it. Be careful. Remember, this is right up next to that asymptote. Calculator will not show it. This whole top part of the graph is going to be missing because it's too close to the asymptote. Be smarter than the calculator. Now tell me all the stuff. Domain, range, X-Intercept, Y-Intercept. What else? Continuity, intervals of increase, decrease, and end behavior. That's a G of X. Okay. Domain. Who's allowed to the party? Right, we got that asymptote. So we're going to cut it off from 0 to infinity with a parenthesis because thou shalt not take log of non-positive numbers. Range. That now is all real numbers. You might be tempted to think that there's a horizontal asymptote here because of how sharply it takes off. It will go all the way down to negative infinity. It's just going to take an awful long time getting there. Luckily, it has infinity to get there. X-intercept. Where did it hit the x-axis? Okay. 9, 0. Right? Y-intercept. No. Bad. Continuity. This has come up a few times before where we mistakenly call this infinite discontinuity. It is not. It is continuous along its entire domain. Okay? So I'd say continuous at 0 to infinity. The reason that we say that is continuity is talking about where in its domain is it discontinuous. So if I normally would have negative infinity to infinity, but there's an asymptote in the middle of that, okay, now there's discontinuity. But if it only exists from asymptote to the right, then it's just continuous there. Okay, increase, never. Decrease, the whole domain. Now we know as we head all the way to infinity, my y's go to negative infinity. Do you remember how we said the left end behavior of this? 0 from the right goes up to positive infinity. Okay. And I try to keep that in line with not just what I know instead of what the book says, but also I try to keep that in line with the way you'll do it in Mr. Spears' classes, for those of you heading on to Trig and Calc. Okay. All right, evaluate each expression, show work to demonstrate the properties, and the work does not have to be a full dissertation. You want to know my work? Ta-da. I showed you that I know when the base of a log and the base of an exponent are the same, they cancel out. And it could be as simple as just that slash. Thou shalt not take log of non-positive. My commandments of domain. Ooh, did we get trapped already? E to the ln. Cancels out, it's -5, I win. Oh, wait, crap. Okay. Sometimes, maybe you have to write 25 to what is 1 over 125. Maybe you can write those in the same base. Okay. You're asking 1/125th is 25 to what power? Well, I have to rewrite both of them as base 5. You will have to do that with something. Maybe you'll have to write them both as base 2 or base 3 or base 4. Okay. This is a really bad 2, by the way. It's a really bad 2. Okay. Am I allowed to have that 0 as an exponent on part D? Well, e to what power makes e to the 0? 1. Okay, now I said ln e1. Okay, e to what power makes e to the first? 0. So you could still do the cancel like that. If you want to show more than that, you can. Do it in stages. Okay. And finally, I'd say 6 to the third is 216. Just using my definition. And if you don't know those off the top of your head by now, well, you're going to be guessing and checking on your calculator. You remember how you get that little cheater chart of all your powers? Go to y2, x squared, y3, x cubed, y4, x to the fourth, y5, x to the fifth, and then just go to an auto-populated table, and it'll tell you all those powers. Okay. Notice there's 5 things. It's just yes or no. Did you do it and did you show something? Okay, expand and condense. To expand, what is the very, very first thing I should do before anything else? Call that 3 squared. And because this is a product, I'll have the ln of 3 squared, and the 2 comes out front as a coefficient. I'll have the ln of x. 3's exponent comes out front as a coefficient. I'll have ln of y to the negative 4th comes out front as a coefficient. If you need to make a note to yourself to break up your coefficient, do it. What happens if I had something like log base 5 of 10? How would I break that up?
Log common base of 10 over log common base 5.
Oh, okay, that's evaluating if I'm going to do a change of base formula. I'm saying expand this, just like this one. Okay, so you split up the factors. This is really, but if I say log base 5 of 2 and log base 5 of 5, are you going to remember to take it to the next step? Log base 5 of 5 is what? Okay. So just be careful about that because they won't always be LNs. Next up, if I'm going to condense, log base 9 of, well, this comes up top. Who does that negative 5 go to? Both of them. So it's log base 9 of 2x to the negative 5th plus log base 9 of x to the 1/3. So x to the 1/3 positive means this will go upstairs, and I'll write it as a third root of x. Downstairs, I have 2x to the negative 5th. The negative is what throws it downstairs. Remember, a difference means it'll be a denominator. Make sure to do both. That's 32x to the 5th. 2 to the 5th and x to the 5th. 2 to the negative 5th is 1 over 32. X to the negative 5th is 1 over x to the 5th. So they just both go downstairs. Well, it's not a negative 32. Right? Because that's log base 9 of 1/32 times 1 over x to the 5th. Okay, that negative throws things downstairs. So maybe a note to just be careful with negatives. If it's a negative in an exponent, that determines numerator or denominator. If it's a negative on a coefficient, that's a whole different realm. Okay? It just stays there. Yeah. So there's 2 back-to-back. There will be like a total of 5 things I'm looking for between the 2 of them. They're not going to be big problems. Next up, solve. We spent a good amount of time on these. Hopefully by now we're good with them. Okay, I'm seeing a couple like, I got this nods. That's good. You can always tell when someone feels confident about a thing because they finish the problem. They like slap their pencil down on the table. Get wrecked, math. Mic drop. Okay. First thing I'm going to do is take the log of both sides. Log of 3, the exponent becomes a coefficient. Log of 6, the exponent becomes a coefficient. When I distribute, be careful how we write it. 2 times x times log of 3 can be 2 times log of 3 times x, which is how I write it. 2 log 3 x's minus 5 log 3, 3 log 6, minus 4 times x times log of 6 can be written as 4 times log of 6 times x. It looks big and bad, but it's no different than ax minus b equals d minus cx. You would still get your x stuff to one side, your not x stuff to the other, and you're still going to divide by that expression. But you have to factor out your x. So I'm going to add this term to the left, 2 log 3 x's plus 4 log 6 x's. I'm going to add this term to the right, 3 log 6 plus 5 log 3. And then I factor out the x. So if I have x and I want x by itself, I'll just divide. Getting 3 log 6 plus 5 log 3 all over 2 log 3 plus 4 log 6. Okay, so you're going to factor out your x and then divide by that stuff. And for the fins in the room, 6 to the third is 216, 3 to the fifth is 243. I ain't doing that. Log of big over 3 squared is 9, 6 to the fourth, 2, 16, 12, 64. I ain't doing that either. You got a calculator, you do it. Okay? If you want to do that, you can. It is not required. But take a look at your instructions. What do we want? We also want the decimal equivalent. Okay? Boy, would that be a good thing to highlight or underline or something like, man, I am so sick of 29 out of 30. Okay, I am so sick of 27 out of 30. I'm going to make sure I write this part down. Okay. You jam it into your calculator, preferably as a fraction if you're in a right view calculator. If you're not, you're going to have to double up your parentheses. Because remember, it puts parentheses on the objects of the logs. But to put these two things together, you need a parenthesis. But to put all of the numerator together and all of the denominator together, you need more parentheses to say this divided by this. Do not speak to me of the ancient magic, witch. I was there when it was written. Okay. I mean, I went all the way through my second year of teaching with a calculator that didn't even show parentheses. It had them, but you just had to remember where they were. But that's just because I was poor. I use was like that's a past tense term. What is this? Ballpark. 1.16. Confirm? Okay. Okay. Solve and answer. Okay, so same thing. Except now, you notice the log of a thing plus log of a thing equals log of a thing, the one-to-one property, I don't have included here. One-to-one property, we learned that in Algebra 2. These are the things that are newish to us. So these are the things I want to have on the test. First up, I'm going to put 3e to the 4x plus 10e to the 2x minus 8 is 0. And I recognize quadratic form. If you are okay factoring it as is, you go ahead. I'm going to write out the full U method and AC factoring for those who don't. So I'm going to say u is, whatever my middle term is, e to the 2x. And I'll replace this as 3u squared plus 10u minus 8. I'll go old school AC. 3 times negative 8 is negative 24. I'm looking for what factors of negative 24 have a sum of 10. Okay? So I split that term and say 3u squared plus 12u minus 2u minus 8 is 0. Cut it in half and say, what does each have in common? They got a 3u in common, leaving a u plus 6. That's a 4. Try that again. These have a negative 2 in common, leaving a u plus 4. Take out my common binomial. U plus 4, womp, womp, leaving a 3u minus 2. But when I go to set these equal to 0 and solve, that's when I'm going to not forget my kid brother at Burger King. I'm going to bring this back in and say it's not really u, it's e to the 2x plus 4 is 0. It's e to the 2x, 3 e to the 2x minus 2 equals 0. And I go to solve both. Subtract 4, ln both sides, break math. Subtract 2, divide by 3, e to the 2x is 2/3. ln of both sides, legal. Divide by 2. Now you can write that as ln of 2/3 over 2, or you can write that as 1/2 ln of 2/3. If you want to thin it and put that 1/2 up as an exponent, you go right ahead, but now you got to rationalize it. Because now it's to the 1/2 power, so now it's a square root, and now you have a square root of a 2 over a square root of a 3, and you need to rationalize that into the ln of, so is it square root is square root of 6 over 9.
So we can't have the half, 1/2?
Oh no, you can leave it like that. I'm saying if you bring it up as a exponent, now you have a radical, and thou shalt not have radicals on the denominator. I suppose I shouldn't use the thou shalt not because it's not a commandment of domain. It's just a don't do that. You know, T'Challa, we don't do that here. Yeah, if you leave it as either one of those, I'm cool. I'm saying if you bring that 1/2 up, you have to be cognizant of what it's saying, and then you'd have to rationalize it. Okay, but if you do that, you're just, again, you're just flexing. Okay, and then whatever that is as a decimal, just give the approximation of it. When I go through, I look at the decimal and the expression. If they're good, I just kind of glance at the work and yeah, it kind of looks like math that we should have been doing. I will sometimes double check the work, like you have the decimal but you don't have the expression. I'm checking the work and okay, you clearly don't know how to do this. You just dumped it in a calculator and calculated zeros and then tried to BS your way through the work. How many times, it's not many of you, but some of you have gotten a test back that says work doesn't match. I know that you BS'd it. And you got points off for that because you're not just showing me the thing that I'm trying to assess. And then calculator. 1 rat per person in New York City. Not true. Close, but not true. Below is a fictional table with data regarding the number of rats in thousands and the city in the given year. There we go, words. Find a logistic model. If you need to put a note on there, Again, I'm going to tell you what model to do. So if it tells you to find a logarithmic model, don't find a logistic. If it says find an exponential model, don't find a power model. Okay? I will tell you what kind to make. Before I go making anything, what do I need to state? What my X is. If I want to start at 1940, that's fine, but I have to say X is the year. If I don't want to start at 1940, then I have to say where I am starting. Where would you like to start?
1930. Does it matter? Or logistic?
No.
I would think
It'll change the model, but it shouldn't change your answer. Okay?
it doesn't matter if you start.
It shouldn't matter. We can do a logistic model with 0. We just did one on our daily quiz. Okay? So what do you want to do? 1900 I'd say is pretty safe. It's also really easy to do because it's just the last 2 digits. Years since 1900. You need to state it, because if your model is different than the model I put on my key, then I'm going to go and make the model doing whatever you said to make sure it matches. So what happens if you just have a model there and you don't say that? I have no idea what you did. And if I can't replicate what you did, then I'm going to have to start taking points off because I don't know what you did. So make sure to state that. Make sure to state that. Put a note to remember to state that. And then, womp, second plus 7 entered 2.
Are we finding the logistic model and determining how many rats are currently at 2022 in the city? Or
Yes, it says currently. No, I'm not one of those teachers that just makes one test and one key and then uses it for the next 10 years. I might use similar problems. I got a whole bank of problems to choose from. But stat, edit. We said since 1900, so it'll be 40, 50, 60, 70, 80, 90, 90, Hondo, over, what was that, 22.6, 52.6. 158, 197, 216.6, 224.9. Well, check my stuff. Looks okay. Specifically said, go find a logistic. So I will calculate a logistic model, store, one, boop, boop, boop.
When we answer, do you want it in thousands or no?
Always thousands.
Like so it wouldn't have the
So in this case, you'd have 229.962 over 502.789. Oh, 1 plus e to the, okay. If you just said 0.1, I would take it. If it bothers you having all that decimal train after those 3 zeros and you want to write negative, or you want to write 0.10009, okay. I said a minimum of thousands. If you go past that, I'll take it. You're more accurate. I'm saying thousands is my minimum, my cutoff. I'll say negative 0.1 x. How? Teaching. Find a logistic model. Determine how many rats are currently in New York City. So I got that. I'm going to go to my table settings. You know what? I don't have to put it over to ask. Could I just do 122 and start there? Right? It's still going to tell me. That don't make sense.
Well, no, you gotta look down. You're on 0.
Oh! What? Why would it start as I said to start at 122?
It's like the 1 under the table.
What the table changes by.
Oh.
It's like where you started it at.
Oops. Okay, that's better. 229 and change. Reading the table explains the table. Reading the problem explains the problem.
So would it be 229,000?
Yes. If you said 229, y'all, there is more than 229 rats in New York City. In fact, I guarantee it's more than 229,000. But I found a random table that had stuff in it, and I had to find words with it. Because the problem in the old worksheet or wherever I pulled this from was literally just find a model. There was no context with it. So just came up with, here, story.
Do you
Okay.
want that rounded up?
229,389-ish rats. Yeah. So there we go. You got yourself a half hour or more. So if you would please, devices over there, scramble yourselves up. Don't sit next to anyone you normally would or you think that I'm going to have an issue with. Let's do this. Please remember, okay, first hour, I don't know why, but first hour, y'all are kind of atrocious about turning your stuff in on quiz day. Please, finish your quiz, turn your stuff in. I want to try to get it done today so that we're all good to go for tomorrow. If there's anyone who's going to be gone tomorrow or does not know if they're going to be gone tomorrow, Chapter 4 packets, top right corner of the shelves. We are starting Chapter 4 tomorrow. Okay.